Students, welcome to Question of Physics. In this class, we are going to learn about uh, the spherical capacitor students, and also we will derive an expression for the capacity of a spherical capacitor. First of all, we have to know that how this spherical capacitor is made, students. It consists of two concentric sphere, students. That too, they are hollow. Listen my words. It consists of two concentric metal spheres. The two, they are hollow, and you'll learn the concentric means what? One is kept over. Let's say first sphere has a radius of RA and the second one has a radius of RB. Here RA is greater than RB. Okay, students. And you have to learn one more important thing here, students. Here these spheres are made electrostatic shielding, students. Okay, they are at electrostatic shielding. And what is this electrostatic shielding? Okay, making a certain space away from the electric field is the electrostatic field shielding, students. Making a certain space free from electric field, students. This phenomenon is known as the electrostatic shielding, students. In general usage, when we use the capacitors, these capacitors are electrostatic shielded, students. You remember this. I told you two concentric spheres are taken. One is served as the inner sphere and second would be the outer sphere. Let's draw the diagram, students. Let's say it is the first sphere, has a radius of RA, students. This radius is RA. Okay, students. Then after we have to give a positive charge to this one, students. We are giving a charge which is positive. Okay. And you learn that when a surface is charged positively, the electric field will be radially outwards. What is it? If you take this the part of the circle, and if you consider this one has a charge of plus q, just imagine, then the electric field would be radially outwards, students. The same thing will happen with this. We are keeping this one inside another concentric sphere, I said, students. We are doing it before. It now. Here I said, I use the word electrostatic shielding, students. Here in this one. Okay. This region is electrostatically shielded, student. That means what? Inside, the electric field is zero. Since the radius of this part is R is less than radius of the sphere, then electric field inside is equal to zero. Do remember, electric field due to this region is equal to zero. And this part is providing the electric field. I told you it will be radially outwards. And we are keeping this sphere. Okay, hollow sphere. Inside, one more sphere, I told you, it is these two spheres are concentric, I said. Means what? They have a common center. And you know what could happen right now? Due to electrostatic induction, opposite charges will be created on inner face of the second sphere, students. Let's say this inner sphere has a radius of RB. This is the radius of the inner sphere. Okay, students. And negative charges will produce on inner surface. Getting me, students? Automatically, the positive charges will created on the outer surface of the second sphere. I am naming it as the sphere B and it is sphere A. Okay, students. Now we are grounding this sphere. In what? We are earthening it. Then this positive charge will flow into the ground. Now, students, we are applying the same thing here. That means electrostatic shielding for the B sphere. Here also, E is equal to 0. Since RB, radius of this one, okay, is less than R. Okay, students. Okay, students. That means what? The potential due to this part, this positive, is equal to 0. Okay, students. Here we have only one potential, which is in between the inner layer of the or inner surface of the second sphere and as well as the first sphere. Okay, this one. And know that this difference only provides the potential. Then I am writing the potential difference between these two in outer of the A and as well as the inner of the B. That is VA minus VB. Okay, students, is equal to Q by 4 pi epsilon naught into RA minus Q by 4 pi epsilon naught into RB. As you know that potential can be had as V is equal to Q by 4 pi epsilon naught into R. We use the same. Here it can also be written as VA minus VB is equal to Q by 4 pi epsilon naught of 1 by RA minus 1 by RB. Okay, students. Or it can be written as VA minus VB is equal to Q by 4 pi epsilon naught into RB minus RA by RA RB. Okay, students. As you know that VA minus VB is equal to Q by 4 pi epsilon naught into RB minus RA by RA RB. And we learn that according to the principle of capacitors, we learned Q is proportional to V, or it can be written as Q is equal to C. We need to find out capacity. That is C is equal to Q by V. Okay, students, and it can be written as Q by VA minus V. Okay, students, then the equation is C is equal to Q by Q upon 4 pi epsilon naught multiplied with RB minus RA by RA RB. The Q get cancels and we get it as C is equal to 4 pi epsilon naught into RA RB by RB minus RA. It is the desired relation, students. Is the formula to calculate the capacity of a spherical capacitor.